This is The Space Shot, episode 244 for January 13th, 2018. Black Holes. Hey everyone, welcome to The Space Shot, your daily space history, pop culture, and news fix. I'm John Molnix. The United Launch Alliance successfully launched the NROL-47 satellite yesterday on a Delta IV rocket. This launch from Vandenberg is the first of the year for ULA. Now I've got some Falcon Heavy news. Chris Gebhardt with NASASpaceflight.com tweeted that SpaceX has now scheduled the Falcon Heavy static fire for Monday. The test window opens at 4 p.m. and goes to 9 p.m. Eastern Standard Time. This morning, a SpaceX Dragon capsule is returning to Earth with around 4,100 pounds of cargo and research material. Dragon can return the largest amount of pressurized payload of any spacecraft in operation, something that's very useful in the post-shuttle era. Soyuz capsules are pretty cram-packed when they're carrying cosmonauts and astronauts, so Dragon has helped fill in the gaps for cargo return to Earth. Dragon departed the ISS early this morning, with splashdown taking place a few hours later. I've got one piece of shuttle history I want to mention very quickly here. The shuttle Endeavour launched on this day in 1993 to deploy a TDRS, or Tracking and Data Relay Satellite, into orbit. STS-54 was a nearly 6-day-long mission, and I'll be linking to the video highlights of that flight in the show notes. Now it's time to talk about black holes. There are different sizes, ranging from the smallest, which are stellar black holes, and they have a mass of between 5 and 100 times that of our Sun. A larger mid-mass type that's been more recently discovered, and finally supermassive black holes that have masses that are millions of times that of our Sun. According to NASA, when a star runs out of nuclear fuel, it will collapse. If the core or central region of the star has a mass that is greater than 3 suns, no known nuclear forces can prevent the core from forming a deep gravitational warp in space called a black hole. A black hole does not have a surface in the usual sense of the word. There's simply a region or boundary in space around a black hole beyond which we cannot see. This boundary is called the event horizon. The radius of the event horizon, proportional to the mass, is very small, only 30 kilometers for a non-spinning black hole with the mass of 10 suns. Anything that passes beyond the event horizon is doomed to be crushed as it descends ever deeper into the gravitational well of the black hole. No visible light, nor X-rays, nor any other form of electromagnetic radiation, nor any particle, no matter how energetic, can escape. I don't know about you, but doomed to be crushed as it descends ever deeper doesn't sound like fun to me. So now that you know a little bit about black holes, let's talk about some history. On January 13th, 1997, NASA announced that 3 black holes were discovered in 3, quote, normal galaxies, which suggested to the astronomers at the time that nearly all galaxies can harbor supermassive black holes. This announcement was made at the 189th meeting of the American Astronomical Society, which fits together with another more recent announcement that I want to talk about today. There's 2 meetings of the American Astronomical Society each year, and this January marks the 231st meeting. Just a few days ago, it was announced that astronomers using observations from the Chandra X-ray Observatory, the Hubble Space Telescope, the Keck Observatory, and the Apache Point Observatory have discovered a supermassive black hole that's burped twice. Scientists have compared images from Chandra and the Hubble Space Telescope to show that this black hole is at the center of the galaxy in question, and it's called SDSS J1354. According to a NASA press release, quote, "The optical data indicate in the past the supermassive black hole appears to have consumed or accreted large amounts of gas while blasting off an outflow of high-energy particles. The outflow eventually switched off, then turned back on about 100,000 years later. This is strong evidence that accreting black holes can switch their power output off and on again over timescales that are short compared to the 13.8 billion year age of the universe. Julie Comerford with the University of Colorado Boulder's Department of Astrophysical and Space Sciences said that, quote, "We are seeing this object feast, burp, and nap, and then feast and burp once again, which theory had predicted. I'm linking to the full press release in the show notes. Check it out if you'd like to see a picture of the double burp." I hope you enjoyed today's episode. I'd appreciate it if you could leave a review on iTunes. If you do that, screenshot the review and send it to me at John Molnix pretty much everywhere on the internet, and I will send you a Space Shot sticker and a little thank you. Also, make sure you hit the subscribe button, that way you don't miss any of the daily episodes. As always, the show notes have more information on today's episode. You can hit me up on Instagram and Twitter. Find me at John Molnix. I'm always up to chat. You can also connect with me on Facebook. Just search The Space Shot or click the link in the show notes. Tomorrow, Huygens lands on Titan. I'm John Molnix, and I'll catch you on the flip side.